Yeah, welcome everyone. I'm super excited to talk about YARA and OSquery today. So let's get into it. I'm living in Denver. This is me out by Buena Vista in Colorado, and started with Upticks about a year ago. And it's a company that's based on OSquery. So I love the open source OSquery tool that turns your operating system, Mac, Linux, Windows endpoint into a SQL engine. And one of the cool features about it that we'll see is that it can incorporate things like YARA. So we're going to talk a little bit about YARA, a little bit about OSquery, and then a little bit about how we can use YARA from inside OSquery to do some real resource efficient scanning of our systems. You can find me on LinkedIn, Julian Wayte. If you guys have any questions after the fact, feel free to enter them into the platform right now. But if you have any follow-up questions over the next few days, then you guys can reach me on LinkedIn. So indicators of compromise, IOC, there are a whole bunch of different types. Traditionally you have URLs, domains, host names, IP addresses. Often malware, when it's downloaded onto your system, it has inside of it a domain generation algorithm, so that it'll be generating a whole bunch of domains, and then the threat actor at some point will register one of these domains. So newly registered domains is a really big IOC. And then you have files. So traditionally we've used file hashes to identify malware, MD5, SHA-1, SHA-256 hashes. But as we know, these things are just too easy to change. If you change any one aspect or entry inside of the file, you'll get a totally different hash. So that's where YARA came about. YARA rules are starting to be used in some cases as IOCs, indicators of compromise, because they typically will specify just one aspect of a file, and we'll talk about that in more detail. Some other indicators of compromise: email addresses, registry keys, startup items for persistence, launch D in Mac, and so on. So if you look at Alien Vault, for example, you can see that here's an example of a published indicator of compromise. We have a couple of SHA-256 hashes, some host names, some MD5 hashes. But as I mentioned, these hashes are starting to become a little bit obsolete, because it's just so easy for a malware developer, threat actor, to change the instance of the malware on each machine that it infects. So a given malware on one machine might have a different hash to what it has on a different machine. And here's an excerpt from the PupiGen, where it actually has a function built in so that it'll automatically randomize the payload for every different machine that you want to install it on, so that it'll have a different hash. So hashes are kind of a little bit outdated, and that's why Victor Alvarez created, he's working at VirusTotal, created YARA. So YARA is a more advanced method for specifying a file signature. It's not based on the entire contents of the file, which is just way too easy to change, to hide the malware, but you specify a signature for a file that's based on strings or binary patterns within the file, as well as a whole bunch of other rules that you can specify about the file, like minimum file length, file encoding method, and so on. YARA is an acronym for YARA, another recursive algorithm. And there's a link here for read the docs on YARA, and you can go in and read all about it at that link. So here's an example of a YARA rule. You can put some metadata in there, description of what it is you're trying to describe. But then essentially it's a list of strings or regular expressions that you can use to categorize strings, and then a condition to say how many of those strings need to match. So in this example, we have 3 strings. The one at the bottom is like a regular ASCII string, and then the top 2 are hexadecimal strings. So if you do a binary dump of the file, you can identify those with hexadecimal strings. And then the condition in this case is saying string A or string B or string C. And you might have different examples, like you might say, oh, I need 2 of those 3 strings. So you can get really complicated in these YARA rules. So they're very powerful ways to, if you find a given malware, to build a rule that will detect that malware, even if the threat actor makes attempts to change the code in different ways. So an important point here, as I mentioned, in addition to strings, you can also specify regular expressions, which is really nice, so that you don't have to limit yourself to a hard-coded string. You have the flexibility to use regexes as well. So at the bottom there, you'll see the condition. So you have a number of strings or regular expressions and then the condition. And you can do some really nice things in the condition. Like here on the right, you'll see condition £A = 6, meaning that you have 6 of those strings inside of the file that you're scanning with YARA. And in this case, the number of string B is greater than 10. So it's looking for greater than 10 instances of that string dummy2 in this case. You can also specify entry points. So you could specify a string, like on the bottom right there, entry point example 1. You have a hexadecimal string, and then the condition is that this string is at the entry point to the file. And then at the very bottom there, we have an example of a condition where it says you have one of any of the ID strings. So you may have ID1, ID2, ID3, ID4, and then your condition can say I need one of the ID strings and 5 of the STR strings, if you had some, STR1, STR2, and so on. So you can get very complex in your condition. On the left, we list a few other types of things you can do in the condition specification in your YARA rules. So you can count the strings, as we just talked about. You can do string offsets. You can do match length. You can specify file size, exact file size, less than a file cutoff, greater than a file cutoff. All of these to help you, reduce your false positives, and in most cases. You can look for certain strings at certain positions, and so on. So there's a whole bunch of YARA rules available as resources on the web. And here's an example for a remote access Trojan. So this one was created by Kevin Breen in 2014. And it's got, in this case, strings A through G, where it's certain ASCII strings were identified within the malware. And then he was saying that the condition is that all of these strings are found. Here's a malware YARA rule for detecting web shell. So in this particular one, he's got a string that's attempting to characterize base 64 decoding. So inside the malware, they've attempted to obfuscate some of the malicious code, and they've encoded it, base 64. And then inside that malware, they're decoding it. And so if he is basically specifying this base 64 decode string, which is identifying where in that malware it's decoding. Then he's got some other things in here, like identifies a string replace, the presence of an MD5 function, GZ inflate, use of a cookie, and the isSet function. So he's defined all those strings and then says the condition, in this case, is 2 of the cookie, 3 of the isSet, and the file size is between 20 and 22 kilobytes. So here's another rule for web shell detection. This one's on Windows. This is the author's Florian Ross. So Florian has created a whole heap of rules that are out there for YARA. So if you go into any of the resources for YARA rules, you might see rules created by Florian. It's fantastic. So this particular one, it's looking for certain code in here, the get metadata, get tables, request get parameters, and so on. You get the idea. A couple of ASCII strings here, and then the condition is that it's looking for all of them. And here's the link to that that rule and a couple of other rules on GitHub, darken code YARA rules. Sometimes malware attacks via PowerShell, and they'll try and obfuscate that. Again, they'll encrypt that in base 64. So there's rules out there to detect base 64 encoded PowerShell. On Windows and other operating systems, you can have variations of system files. And so this rule here, again by Florian, is looking on Windows where they've changed the iExplore.exe, and it's now malware. And so this YARA rule is saying here are the strings that should be in a typical iExplore.exe, and if it doesn't have all of these strings, i.e. not one of $win*, and the file matches iExplore.exe, then this YARA rule will fire. So you can be looking for the presence of certain things or the absence of certain things within YARA. So we're starting to see a few YARA rules published as IOCs. So you can see here there's a pulse on Alien Bolt, and it's at the bottom here, it's specifying a bunch of SHA-256 hashes. There's 524 of those, and there's one YARA rule. So it's good to see that YARA is starting to get a little bit of traction. And often what you'll find is threat researchers will perhaps detect a malicious piece of malware somewhere, and then they'll write their own YARA rule to detect any other versions of that malware on their system. Then they'll run a scan on several machines or their entire fleet, and if they detect maybe several different variants that they think are related to that malware, then they'll publish those on a pulse, and they'll publish the SHA-256 and MD5 hashes. So the hashes are still being used a lot, MD5 hashes, SHA-1, SHA-256, because it's fairly efficient for people to scan their entire fleet, and they don't want to have too much of an impact on their computing resources, because running a YARA scan is a bit more intensive than just calculating the SHA-256 hash of a file to see if it's malicious. So we're going to talk a little bit more about how we can reduce some of the impact of doing YARA scans. So YARA's been around since about 2014, I think, and some really cool tools that are now available. Airbnb wrote one called Binary Alert, and what that does is it's serverless. So if you're sending data up to AWS and you're dumping it to an S3 bucket, then the binary alert can be used to run a YARA scan of the data as it's going to your S3 bucket. So that's pretty nice. You can do a configurable set of YARA rules with this. So you might have one file that has a bunch of YARA rules, or multiple files that have different rule sets. But that's very nice if you're using AWS S3. There's a nice tool called CAPE, which is config and payload extraction. So that's an extension for Cuckoo, which is a malware sandbox. So it can detect a bunch of different techniques and behaviors inside of malwares and pull out the specific payloads around indicators of compromise. If there's malicious IP addresses or domains that are being accessed inside of that malware, then CAPE can help pull them out for you. If you're using Windows and you want to do event logs analysis, then ELAT is a cool tool that helps you use YARA inside of Windows for event logs. And also, if you're dealing with a bunch of files, there's a file scanning framework from Emerson, and that recursively allows you to scan through multiple files in different locations and use YARA to detect something. And then the file scanning framework will allow you to put in some programmable logic to do A, B, or C, like typically to try and take out a payload or parse a configuration file. So that's nice. There's a bunch of resources here where you can find a bunch of cool YARA rules for detecting APT threats and other things. There's a nice integration of YARA with Python. If you guys use a lot of Python internally, then GitHub VirusTotal YARA Python has a module where you can do a bunch of things with YARA. There's the official YARA Read the Docs site here, and a GitHub site with a whole bunch of YARA rules. There's an awesome YARA inquest link here for GitHub. It's in the vein of awesome PHP, and that's got a lot of related resources. So how do you use YARA? Well, you can install it pretty easy. It's just a small binary, runs on Linux and Windows and Mac. An example here on Ubuntu, you can do an apt get install. YARA on Red Hat or CentOS, you can do a yum install. Windows, you can install it with Choco. Mac OS, you can install it with Brew. But once it's installed, it's really easy to run. So here's an example at the bottom of running YARA. You just run YARA with a file containing your rules, and then you give it the file that you want to scan, or you give it the directory that you want to scan. So typically, your YARA file, a rules file, have a bunch of different rules in it. And in my particular case, I had a bunch of rules. One of the rules was looking for the evil OSX remote access Trojan, and on Mac, and this YARA scan scanned the temp directory and found this launcher 3AA514. It's a Python-based remote access Trojan. So very easy to use. But it's a little bit different, as I mentioned before, than doing a MD5 or SHA-1 or SHA-256, because you could have a large number of rules, and the rules themselves could be specifying a bunch of strings and a bunch of regular expressions, and some of the strings could be fairly short, which means you could be getting a lot of matches. So how resource intensive is it to run YARA scans? So I did some tests. I had a Linux machine, and I scanned the etc, the lib, the var, and the user directories. And you can see there I had about 2,000, 23,000, 24,000, and 604,000 files respectively in those different locations. And there were the times to scan those different files there: half a second, 11, 17, 123, total about 151 seconds to scan all those files on my computer. So it's about It's a pretty linear progression. So the more files that you're going to scan, the more time it's going to take. And this was just with the 9 rules in my YARA rules file. So you can see here that if you have a larger number of rules, that it's going to take more time as well. So these tests show that as we increase the number of rules from 1 to 122 on the same set of files, in this case was just scanning the lib directory on Linux, about 128,000 files. It went from about 20 seconds to 258 seconds. So as you increase the number of rules, it's going to increase your scan time. And one of the nice things about YARA is that when you run it, if you have rules that you've built that are not going to perform that well, then YARA will help tell you about it. It'll give you these warnings. So in this particular case, I had a rule on line 214 that had a string A that had .star, and it's saying, oh, consider using .n instead with a reasonable value for n. It'll give you better performance. Another example here on line 830, I had another string in my YARA rule that it said, hey, this is really slowing down your scanning, so you should look at it. And then on line 1148, I had a regular expression. Again, it said, hey, that's slowing down your scanning. It's not as critical as the one before, but those are the kind of things you can address. And that'll be shown to you when you just run the YARA scan with the YARA rules file and then a given file or a directory. So it allows you to tune your rules a little bit based on the recommendations that they're giving you. So once I've gone through and done some tuning on my rules and reduced the amount of resources it was using, I want to kind of show, you know, when we do these scans of 20 or 100,000 files on these machines, how many resources is it using? Is it using a fairly small amount of resources, or is it using the whole set of resources on the machine? So in my machine, I had 2 processors, 2 processors, and it was using about 197% or 193%, meaning it was fully using the 2 cores that I had on that machine. So full YARA scans can be fairly intensive. So it's not really possible or efficient to run regular full scans of your systems, especially if you have a large number of YARA rules. So what's a better way of doing this? Well, you could use some of those tools that we looked at before. You know, if you're dumping data to your S3 bucket, to use that Airbnb program, or you could maybe, if you had some Python programs, you want to use the YARA Python module, you could do that. But OSquery is a really nice open source tool that you can use for DevOps and security and fleet visibility applications. And it's got some really nice features inside of it where you can kind of turn the operating system into a database, but it also allows you to do FIM, or file integrity monitoring, which is basically monitoring files for changes. So if a malware comes into your system, you're going to have a change to that directory. You're going to have a new file, or it's going to update an existing file. So with FIM, file integrity monitoring, inside of OSquery, you can use that to say, hey, I'm not going to scan my whole computer server all the time, but if I monitor certain critical locations, then FIM will tell me that that change occurred, and then I'm going to YARA scan it. And you can do that with OSquery. The other thing OSquery can do is it can identify what processes are running. So you can do a select star from processes with OSquery. You'll get a list of all of the processes, and that's nice. So you can say, oh, I'm not going to scan everything on my machine, but all of the processes that start up, I'm going to scan those things with YARA. So that's what we're going to see how to do here. So let's talk a little bit about OSquery. Here's an example of a query. So you can install OSquery. It's a fairly small agent, and you can go ahead and install it. I'm going to go to this website here very briefly, osquery.io. So you can just go here and download OSquery for current version is 4.3 for Mac, Linux, and on Linux there's a CentOS a Red Hat version. There's a version for Ubuntu, and you can also do it for Windows. So OSquery is a really nice agent for, let me just go back to the presentation, for doing SQL queries against your endpoint. You don't have to say PS minus EF and then grep for certain things. You can just do it all with SQL. So here's an example where it's selecting some things from the processes table, and you can just use a where clause just like you do in regular SQL. So one of the nice things about OSquery is that it has this column on disk. It's true or false, 0 or 1. So you could select for all the processes that are running, if on disk equals 0, it means that there's no longer a file on disk that corresponds to the process that kicked off. And that's sometimes what happens with a malware method for evading detection, is it'll spawn a process and then it'll delete the on disk file, and then it'll just be running in memory, and you won't be able to detect it with antivirus scans that are looking at the files. But that's just one example of a query that you can do in OSquery. OSquery, you can select from the processes, as we see here. You can select from the process open sockets to see the remote network connections that your machines are making. And then you can select from the configuration files, things like see the packages that are installed, so RPM packages on Red Hat or deb packages on Ubuntu. You can see all your configurations, so you can select from ELF, the application firewall on Mac, and a bunch of other things. There's tables for Docker or container telemetry, and really you can get a lot of information from OSquery. So it was built originally by Facebook because they had all these different endpoint agents, and they were using a bunch of resources on their machines, and they said we just need one endpoint agent that can give us all of the telemetry we need at a relatively low CPU impact on those endpoints. And they didn't want it to be a kernel-based agent where you upgrade your Linux kernel and you potentially have the risk of crashing your machines and stuff like that. So OSquery, a very nice agent, and the way it works is you can install it and then you can run the OSquery I as an interactive shell, and you can just do a query like select star from processes, or more often people run the daemon OSquery D, and you specify in the configuration file, the conf file, the queries that you want to run and what interval you want to run those. So you could be saying, oh, I want to take the processes every 30 seconds. I want to get the USB devices every 60 seconds. Like you can see here, they have a select vendor model from USB devices, and they're running that every 60 seconds. And select your RPM packages or your ELF configuration, or any of the 240 or 257 now tables now that are available across Windows, Mac, and Linux. So there's a lot of telemetry, and you can specify in your OSquery D configuration which of these queries you want to run on a regular basis. So this is a nice resource. If you say, oh, does OSquery have this telemetry, then you can go in and look and say, oh, I want to know information on ELF and on Linux, and is that available? And yes, it is. If you want to say, oh, I need to know information on processes and what operating systems are they supported on. So I go down here to processes, and we can get processes from Mac, Linux, and Windows. And it also supports FreeBSD as well. And it'll tell you all the different columns you can get. So, you know, if you look at something like ALF, which I mentioned earlier, the application layer firewall, then that's the OSX information about the firewall. So that's only available on Mac. And if you want to go see the, you say, oh, I only have Linux. So you can click Linux here and it'll drop down and just give you the 149 tables that are available on Linux. So it's a really nice resource, and OSquery is a really nice open source tool. So you can specify the queries that you want to run in the daemon on a regular basis and the interval with which they run. And then they'll just run in the background, and then they'll send the data out to your consumer, whether it's syslog, or if you wanted to send the data, you maybe pushing it into an ELK stack, or sending the data to a SIM like Splunk or Sumo. Then you just specify in your configuration what queries you want to run. And OSquery can also do the FIM that I mentioned, the file integrity monitoring. So this allows you to specify configuration in your OSquery D to say these particular files in these locations. So you might want to monitor the system files in the etc, or you might want to monitor the user downloads, for example. So in your OSquery daemon configuration, you'd specify those paths under the file monitoring section, and then any changes to files in those locations would be captured, and they'd be written to the OSquery daemon output, which, as I mentioned, you could send those to whatever consumer you want to use. But a nice thing about the file integrity monitoring is if you're using FIM to detect a change to a file, you can then say, hey, now run a YARA scan on those files that have changed. And for monitoring processes that have happened, as I mentioned, you can see all of the different processes that run on a machine. So you might put in the OSquery daemon configuration, give me all the processes, select start from processes, interval 30. So every 30 seconds, select start from processes. So the daemon will run in the background, it'll do that, it'll push that data out to the consumer, and it'll give you change data. So if you have 50 different processes running when the OSquery daemon starts up, it'll give you that list of the 50 processes. Then 30 seconds later, if you've specified in the OSquery conf daemon config to run on an interval of 30 seconds, and there's 3 new processes, then the output will be those 3 new processes after 30 seconds. But what happens if a malware process runs for 1 second in between the 30-second intervals of it capturing the process? It's not going to know about it, because if it started and finished before the next query run, then it's going to go unnoticed. And so OSquery developers recognize this and introduced a pub/sub framework, what they call the eventing framework, so that as soon as a process runs, and there are eventing framework applies to processes, also applies to other things like file changes, network activity in the socket events table. But as soon as one of these event things happen, like a process runs, even for a split second, it'll be written to or published to the data backing store. It's a RocksDB is running on the back end. And then when you run a query, like every 30 seconds, it'll subscribe to get you all of the things that changed. So that malware that runs for a split second in between the two 30-second intervals will be captured in the eventing framework. So the process events table will have it. The processes table may not. So that's the eventing framework in a nutshell for OSquery. And it's really nice from a security point of view, because when you're using this, it will make sure that nothing is missed. Now, some really high volume customers, if you have some really big Linux servers and you turn on the eventing framework and you start to capture every single process event and every single socket event for network activities, particularly network activity can be really high volume. So if you start to see, oh wow, I turned on OSquery and everything was good on my laptops, but on my big servers, I turned on socket event capturing, and now I'm noticing a noticeable load on the resources, CPU, etc. There can be a little bit of a resource usage from the eventing framework on high volumes of events, so just be aware of that. At Uptex, we introduced a cool feature where we're actually disabling the staging of those events on the machine, because writing to RocksDB and reading from RocksDB all the time can be a little bit of a resource drain. But we just at Uptex send them directly to a lightweight HTTP send to the back end. So that'll help if you ever need to have a bunch of event data capture in OSquery, but you're running into performance issues, then just keep that in mind. So we can install OSquery really easily. Here's an example on a CentOS machines. Just you can download it from that site that I showed you, the osquery.io, or you could do like a wget or something, and then you just install it. So the RPM version, just RPM-I, and that'll install OSquery. And then you can run the YARA that's part of it. You don't have to install YARA separately because OSquery comes with YARA built in. But once OSquery is installed, then you can run the OSquery I to do an interactive query, like select star from processes. Or you can specify a daemon configuration file, a conf file, that says, I want to run these queries. Or you can download, instead of having to work out what queries you want to run, there's a bunch of open source query packs that are available. And they're just a set of queries that people have developed. They said, hey, for monitoring, these are some nice queries that you should use. For security related applications, these are some nice queries that you can use. So you can download those query packs, specify them in your OSquery D configuration, start up the OSquery daemon, and then they'll start to run those queries and give you that telemetry. So we're going to go ahead and set up OSquery here to use YARA. So the first use case is going to be for doing a YARA scan of any files that change. So we might want to, for example, monitor the SSH keys inside of Linux, or we might have certain sensitive directories, like there's a private directory inside of the home directory of all of the users, and we want to do file integrity monitoring to notice if there's any reads perhaps of those files, to make sure that users who shouldn't be reading them are not reading them. So you can specify the files to monitor for FIM, but you can also specify the YARA configuration, which are the signature groups. So YARA calls the rules for YARA signatures. So a .yar file with YARA rules is just a .sig file in OSquery. So you can say, okay, for OSquery, I want to use this set of 60 YARA rules. So that's going to be my signature group. You could have multiple YARA rules file in a signature group. You could have multiple signature groups. And then you just say, what are the files that I want to monitor? So that's the file path section for your configuration in OSquery. And then you map the file path sections to the YARA rules that you want to scan. And that's it. So once you've done that, and you get any file changes, and they'll trigger an OSquery FIM event, and then it'll do the corresponding YARA scan of those files. So here's what that would look like. In this particular case, I set up a set of YARA rules to scan the downloads directory. So I set up a FIM configuration for the user's download directory, and then the files that were downloaded from the web application, for example, you're running Firefox, Chrome, whatever, and then you download files, and then you can scan using YARA automatically any files that get created. In this particular example, we had a whole bunch of files that were downloaded. They just we just put a null rule in here called file event condition equals true inside of YARA. If you've ever used OSquery, and you'll know that when you do file integrity monitoring, you can generate records in the file events table, but once you start turning on the YARA events with the configuration like we just saw, you won't get things in the file events table. You just get them in the YARA events table. So this true rule just allows you to see the things that didn't hit a YARA rule, but they did create a FIM event. So these are all things that are files that have been downloaded, but this is one here at the bottom that actually hit a non-trivial YARA rule, and it was the Evil OSX remote access Trojan was downloaded. So that's a really nice way of doing targeted YARA scans on files that are in certain directories that you're monitoring. So you know in certain machines that you want to look at certain folders, you can turn on FIM and then tell OSquery to do YARA scans against those.
Hey, Julian, just a heads up, you're at the 10-minute mark.
Okay, yeah, perfect. That is excellent. Okay, so now let's look at the other use case where we want to say, oh, I don't necessarily know what folders that I want to monitor for changes using FIM. I just want to use the OSquery pub/sub framework that tells me every single process that ran through the process events table, and all the processes that run a YARA scan on those. So in order to do that, you need to turn on the scanning of the pub/sub framework to give you the process information in the process events table. So you say disable events equals false, and disable audit equals false, and then you'll start to get process events. Then you go ahead and you put in the information on the YARA files that you want to use, like this rule 60 sig file, set of 60 YARA rules in the signature group. And then you can run a query here. This is an interactive query, OSquery I. If you want to try this out for yourself, it's a real easy way to test it. You can just start OSquery interactive shell with the OSquery I command, and then you can specify your own configuration file, which we had here. This was our conf file, which said we're going to be using these YARA rules files. So if you start OSquery, the interactive shell, with these flags, then it will enable the pub/sub framework to give you the process events. And then if a malware process starts, you can use a query like this, which is really nice. So you can say, do a manual YARA scan, i.e. select star from YARA, where the path that you want to scan, you don't want to scan the whole computer, as we saw before, it was too much resources. So we're just going to say, let's do a YARA scan where the path is in this other query, which is just select all the paths shown in the process events, which is, you know, OSquery's pub/sub framework is showing you a list of all of the processes that ran on the machine. And then in this case, we're saying sig group equals sig group 1, which is, you know, we had multiple signature group, different files with different YARA rule sets. And in this particular case, it'll show you if any files got started that matched any of the YARA rules for malware, for example. And here we had a hit here on the anglerworm malware. So you can do this very easily to test things out for yourself, but you normally want to not be doing the OSquery I interactive and doing queries. You want to make it automatic and part of the daemon. So you would have a setup like this, where you put in your YARA configuration to say, hey, I'm using these sets of YARA rules. And then in my schedule, I'm running the query that we just saw, which was select start from YARA. I do a manual YARA scan of files that are path of all the distinct paths from the processes that ran on your machine. So if you were to put something like this in your OSquery D configuration, start up the OSquery daemon, if a malware ever ran on your machine, any process that starts is going to get scanned with YARA. And so if you have a YARA, set of YARA rules that is, going to match this malware, so you downloaded a whole bunch, maybe from some open source site, then if you looked at, if you're sending into your SIM like Sumo, or if you just want to manually test it on your machine, you can look at the output of the OSquery daemon, which is in the var log OSquery daemon results.log, and you can see that you'll get a hit. OSquery daemon will, have run the YARA scan on the processes, and you get a hit, and you'll see that, yeah, you're automatically now detecting with YARA any malicious activity, so long as the process runs. And it's as easy as that. So the resource usage, when you look at doing it this way, is really a lot less, because you're typically only processing very few files if you're using the file integrity monitoring change files approach, or you're doing very few files if you're using the process events approach, where every process that runs on your machine, I'm going to do a YARA scan. Instead of using 198% on a 2-core machine, you're using like 6%. So using YARA and OSquery together is a super nice way of really reducing the amount of scanning that you're doing, but still having a pretty good stab at scanning those things which are important. So it's pretty good timing there. I think that's basically it. In conclusion, YARA is a great Swiss Army knife for doing malware scanning. It's a really superior method for specifying signatures for files compared to MD5, SHA-1, SHA-256, because the threat actors can't modify a file very easily to avoid a YARA scan if the rules are written nicely. But it can be intensive to run YARA scans on a large number of files, large number of machines. So using the OSquery file change and process change method to do scans with YARA on changed files or processes that ran is a really resource efficient way of doing YARA. So that's it. Let's look if we've got any questions from anyone.
Awesome, thank you, Julian. So one thing I wanted to let everybody know, Upticks has had someone answering all the questions that have come up in the Discord channel. They've been killing it. Because we're a little tight on time, I'm going to avoid asking those questions and direct everyone to there. The one question we got through GoToWebinar is, what is the best way to go about scanning Word macros?
To go about scanning Word macros?
Yes.
Yeah. There's applications that you can get to dump Word macros. And then if you had, I'll have to see if there's any resources for YARA rules for Word macros, but you might want to look at the Python hooks. So I think there's ways where you can extract the Word macros with Python and then run YARA scans that way. Yeah,
Awesome.
because I know YARA is being used to do similar things with other macros and memory scans as well. So that's what I would recommend, is to look at the Python module.
Okay, another question we have, since I think we have time for one more, is from Jay President. How do you defend if you do not know the files that might change?
Right. Then I would set up the file integrity monitoring to monitor high-risk directories such as user downloads, and I would use the process approach, where if you don't know what files would change, just set YARA to scan all of the processes that run. Yep.